The title of this video says, "The End of Aluminum." Sounds dramatic, right? Maybe even a little insane. But stick with me, because by the end of this, it'll make perfect sense. And honestly, you might even agree, because what Xiaomi just pulled off completely changes how cars are built. So much so that traditional aluminum suddenly feels ancient, like museum-level tech. Let's rewind to 2021. A company known for budget smartphones, air fryers, and electric scooters walks into a room and says, "We're building a car. Not just any car. A car faster around the Nürburgring than a Porsche. A car stiffer than a Bugatti. A car where the chassis isn't welded, but basically printed, in under 2 minutes per section." Yeah. People laughed. Hard. But fast forward 3 years, and nobody's laughing anymore. The Xiaomi SU7 Ultra is real. It's already on the road, and it just clocked a Nürburgring lap time of 6 minutes and 46 seconds, beating the Porsche Taycan Turbo GT. And the wildest part? It's not the speed. It's how this thing is built. Xiaomi didn't just make a fast car. They scrapped over 100 years of automotive tradition and started from zero. No old-school welding, no stamping hundreds of steel parts, no massive heat ovens. Instead, they used AI to create an entirely new type of metal, something that literally didn't exist before. Then they built a machine the size of 2 basketball courts to shape it. And then, this is the crazy part, they turned the battery itself into the structural skeleton of the car. What they've created is so different, it almost sounds fake, like something out of a video game. But it's real. Every number, every claim, backed by machines already running in their Beijing factory right now. And by the end of this, you'll understand exactly how they did it, and why the entire auto industry is now scrambling to catch up. So let's start at the root of the problem. Here's something most people never think about. The way we build cars today is basically the same as the 1950s. Flat sheets of steel, stamped into shape, then welded together. Hundreds of parts, thousands of welds. That's it. That's the system. Think of it like making a cardboard box. You cut flat pieces, fold them, and tape them together. It works. But every fold is a weak point. Every joint is a risk. The more pieces you add, the heavier and messier it gets. Cars are no different. Every weld adds weight. Every weld vibrates. Every weld can become a problem over time. Sure, engineers have optimized it, but the core idea hasn't changed. Then EVs showed up and made everything worse. Electric cars need massive batteries, and the easiest place to put them? Under the floor. But now you've got this giant, heavy battery pack just sitting there, basically dead weight. So you need a stronger chassis to support it, which makes the car heavier, which means you need a bigger battery, which adds more weight. And just like that, you're stuck in a loop. Tesla tried to break this cycle with something called gigacasting. Instead of welding dozens of parts together, they pour molten aluminum into huge molds and create massive single-piece sections. Fewer parts, less weight, faster production. Genuinely brilliant. But there's a catch, a big one. Because when aluminum cools down after casting, it might look solid on the outside. But inside, it's not nearly as strong as you'd think. And that hidden weakness is exactly the problem that stopped everyone else from copying Tesla. And solving that problem? That's where Xiaomi changes the game. At a microscopic level, metal isn't as perfect as it looks. It's made up of tiny crystal structures, and in regular cast aluminum, those crystals are scattered in random directions. From the outside, the part looks solid, but under real stress, it can crack, bend, or fail. To fix this, manufacturers use something called heat treatment. They take the cast metal and place it inside massive industrial ovens, heating it to extremely high temperatures for hours. This process realigns those tiny crystal structures, turning the material from brittle and weak into something strong and durable. Think of it like baking bread. Same ingredients, but raw dough and a fully baked loaf are completely different. Sounds simple enough, right? Here's the problem. When you heat a large, complex metal part to those temperatures, it doesn't just get stronger. It also moves. It warps. It twists. It changes shape in tiny but critical ways. And in something like a car chassis, where precision down to the millimeter matters, even the smallest distortion can cause serious issues. Doors stop aligning properly. Suspension points shift. Parts don't fit the way they should. Suddenly, the entire structure becomes a nightmare to assemble. So, manufacturers were stuck with a painful trade-off. Skip heat treatment and get a part that has the right shape but isn't strong enough, or use heat treatment and get strength but lose perfect accuracy. Either way, you're compromising. Every major automaker has tried to solve this problem. Some spent years researching it. Most eventually gave up and built their entire process around this limitation. It became one of those unsolvable problems the industry just learned to live with. But Xiaomi didn't accept that. Their engineers tested every aluminum alloy available on the market. None of them could meet all the requirements at once. Strong, flexible, stable, and able to skip heat treatment entirely. The perfect material simply didn't exist. So instead of settling for the least bad option, they decided to create their own. And this is where things get really interesting. Xiaomi built a deep learning AI system called Material Genome. Think of it as a scientist that never sleeps, never gets tired, and can run millions of experiments at the same time, inside a computer. They fed it everything we know about metals, alloys, and material science. Then they gave it one clear mission: create a new alloy that is strong, flexible, precise, and requires zero heat treatment after casting. What happened next is insane. The AI simulated over 10 million different alloy combinations. To put that into perspective, if a human scientist tested one new alloy every single day without ever taking a break, it would take more than 27,000 years to reach that number. The AI did it in a tiny fraction of that time. It tested combinations of aluminum, silicon, magnesium, and rare earth elements across billions of virtual scenarios, searching for the one perfect formula that checks every box. Here's a simple way to imagine it. It's like trying to bake the perfect chocolate chip cookie. Normally, you might test a handful of recipes over a few weekends, but imagine simulating 10 million recipes in a computer, testing every possible variation of ingredients, temperature, and timing, until you find the one recipe that turns out perfect every single time. That's exactly what Xiaomi did, except instead of cookies, they were designing the molecular structure of an entirely new metal. The result is something they call Titan metal, a fully patented alloy exclusive to Xiaomi. And here's the breakthrough. When this metal cools after being cast, it's already strong, already precise, already the exact shape it needs to be. No oven, no warping, no compromise. In real-world terms, this changes everything. The production line becomes faster. Energy consumption drops. Parts come out with incredibly high precision. They fit together better. Tolerances are tighter. The entire system improves, just from one innovation at the material level. But creating a revolutionary new metal is only half the story, because you still need a machine powerful enough to actually use it. And what Xiaomi built next barely feels real. Now let's talk about the machine that basically prints a car chassis. When Tesla first revealed its Giga Press, it was rated at 9,000 tons of clamping force. At the time, engineers and journalists called it the absolute limit of what humans could build. The kind of machine that makes even experienced engineers go silent when they see it in person. Xiaomi looked at that and went a step further. They built a 9,100-ton version and named it the hypercasting machine. And this isn't just a slightly bigger number on paper. This machine is massive. It spans the size of 2 basketball courts placed side by side. It weighs over 1,000 tons on its own. It heats their custom Titan metal to around 700 degrees Celsius and then injects it into a precision mold at incredible speed. So fast, in fact, that air bubbles don't even have time to form inside the metal. And that detail matters more than you might think. Air bubbles inside cast metal are basically invisible weaknesses. From the outside, everything looks perfect, but under real stress, those tiny pockets can turn into cracks. By injecting the metal this quickly, Xiaomi eliminates those weak points. The result is a level of internal density you'd normally expect in aerospace components. Every cubic millimeter is solid. Now here's what this machine actually does in production. Take the rear floor section of a car, one of the most critical structural parts. In a traditional car, that section is made from 72 separate steel parts, all welded together with around 840 weld points. Each piece has to be manufactured separately, then transported, stored, aligned, clamped, and welded together, step by step. The whole process takes hours, multiple machines, and a lot of manpower. Xiaomi's hypercasting machine? It produces that entire section as one single piece in about 100 seconds. 72 parts become one. 840 welds become 0. Hours of work become just over a minute. And it gets even better. That single-piece structure is about 17% lighter than the traditional steel version. It also reduces road noise by around 2 decibels because there are no tiny gaps or weld points vibrating against each other at highway speeds. But the process doesn't stop once the part is made. Every single piece is instantly scanned using X-ray imaging and high-precision laser sensors right there in the machine. If the AI-driven quality system detects even the smallest flaw, the part is automatically rejected before a human ever sees it. The level of inspection is beyond human capability, both in speed and precision. Incredibly, a brand new chassis section rolls off this machine roughly every 90 seconds. And if you think that is the most impressive part, what Xiaomi did with the battery might surprise you even more. Let's talk about the battery. In most electric cars today, the battery is basically a giant, heavy box bolted underneath the vehicle. It does one job: store energy. It doesn't help structurally. It doesn't make the car stronger. It just sits there, adding weight while powering the motors. Xiaomi looked at this and asked a simple question. What if the battery wasn't just a passenger? What if it was part of the skeleton? That idea led to something called CTB technology, cell-to-body. Instead of placing the battery inside a separate box, Xiaomi integrates the battery cells directly into the car's structure. The top of the battery pack actually becomes the floor of the cabin, the surface your feet rest on. And the cells underneath aren't just storing energy anymore, they're helping hold the entire car together. But Xiaomi didn't stop there. They made one more design choice that sounds strange at first, but is actually incredibly smart. They flipped the battery cells upside down. Here's why that matters. Every battery cell has a small safety feature called a pressure relief valve. If the battery overheats, this valve releases hot gas to prevent dangerous buildup. In most designs, these valves face upward, toward the passengers. To protect people, engineers have to add thick protective layers between the battery and the cabin floor. That adds both height and weight. By flipping the cells upside down, Xiaomi points those valves downward, toward the road and away from passengers.